सो गुड इवनिंग बच्चा लोग। हाउ आर यू? आई एम फाइन। मैं तो बहुत अच्छा हूँ। आप कैसे हैं? अरे हैप्पी न्यू ईयर यार, ये भी तो आने वाला है। आई जस्ट फॉरगॉट। क्योंकि हर साल ही आता है ना इसलिए। ओके, सो हैप्पी न्यू ईयर टू यू आल्सो इन एडवांस, बिकॉज न्यू ईयर पे हम नहीं मिल पाएंगे। वी आर नॉट एबल टू टेक लेक्चर्स। हाँ, सो वेरी हैप्पी न्यू ईयर टू यू ऑल। आशिरा, JNV Ramnagar student. So we will wait for 1 or 2 minutes more, let the others to be joined, and then we will move further in the lecture. This is the new topic, surface tension, and probably this will be the last lecture of this topic and the first lecture of this topic. Okay, so tell me about yourself. How is feeling? How you are feeling today? कैसा दिन है आज का? Hello Virendra. I think you are from JNV Baleri, na? Yeah, correct ना? कौन बने करोड़पति में जीत गया हूँ अब, सही जवाब पे। ओके, Hashira is not responding. Hashira, I think she has just joined and okay, I got it. Oh, yeah. I'm sorry. I didn't mean to do that, but good evening also. Good evening, Hashira. As you are not responding now, so I was thinking ki you are just taking a nap and anything else. Okay. I used to take many classes in a day, but this is my one of the best class I will take. I enjoy a lot with you guys. I don't know about you. I think you might be feel bored and all. हाँ, ऐसा है क्या? I will enjoy with you. I usually enjoy this lecture. Okay, so we will start. So we will start at 17:05. Okay, means 5 बज के 5 मिनट पर we will start. Till then, we will have some talks about about yourself. Okay. So tell me something about yourself. Student of JNV Ramnagara, Virendra, student of JNV Baleri, Hashira. What are your hobbies? Acha, do you like singing? Anyone who sings? No one. Are very awkward situation. Okay. And I'm just asking you about your hobbies. Do you like singing? Uh, that's what I'm asking. Okay, got it. I also like singing, but mostly in my kitchen or in my bathroom. Okay. So you like eating. Very good. This is the wonderful, wonderful hobby that you have. A student of JNV Valeri. Sing a song. No, no, I'm not going to sing a song. I will sing a song for you when I'm giving you treat. When you clear your JEE mains or NEET examination, whatever you are attempting for, then I will give you a proper treat and I will sing for you at that time. And I will promise you, I'll do the same. Got it? Okay. So it's 17:05. Let's get started with the lecture. So today's topic is surface tension. No, no, please mat kaho yaar. Don't say this. We have an understanding, na? You understand me, I understood you. So now back to the lecture. Okay, JNV Ramnagar student. Gives me a thumbs up, guys. Okay, got it. So today we are going to learn about surface tension, what it is, surface energy, capillary lies, excess pressure in a bubble, how it forms, all the things we are going to do today in this lecture. So without wasting time, let's get started. So we will firstly describe the topics that we have to learn. This is surface tension. Learning objectives for today's are adhesive forces and cohesive forces. And what it is, I will discuss it. Then surface tension, excess pressure inside a liquid drop, air bubble, and soap bubble. So these three things you have seen already. Air bubble you have also seen. Liquid drops you have also seen. Soap bubbles, you might have used that toy which we used to blow the bubbles in air with the help of detergent and all. Okay. Then the angle of contact and capillarity. The capillary lies, you have also heard about this term, capillary, I think. So we will discuss it today. Now, adhesive forces and cohesive forces. Now, what is the adhesive forces? The very basic thing is this. So, adhesive forces are the forces which are attractive in nature, first of all. These are the attractive force. And these forces apply between the different molecules. Okay. Different molecule has a kind of attractive force in between them. That force is termed as adhesive forces. For example, when you take bath, you drop liquid, which is probably water, I think. So when you drop that, so it will just wet you, huh? And you have to use your towel to remove it, which means that molecules of our body or skin and molecules of water attract each other with the help of these adhesive forces. Got it? If you do the same with mercury, it will not get you wet. No, because there is no kind of adhesive forces formed between our skin or this mercury. Got it? So the same example you can see here. Now the same thing is cohesive, but in a different way. Cohesive force is that force which usually attractive in nature, but it applies with the same material. Same materials के जो molecules हैं, the molecules of same material, they attract each other, bind with each other, make contact with the help of these cohesive forces. The forces between them is termed as cohesive forces. Okay. Now, it will be possible that water and water molecule has some cohesive forces in between them, and our skin molecules also have cohesive forces. Then why they are making contact and making attraction with water? Why our skin is making attraction with water? Because there, in that contact, the cohesive forces is less dominating in nature. Adhesive forces there are dominating in nature. So that is why slide is not visible. This slide is not visible to you. Cohesive forces. What happening? Just a second. Now, is it visible to you now? Okay. I think this is only cohesive force, na? So you are saying I haven't played it. So that is why it is not seen to you. Got it. You are welcome here. So cohesive forces are the forces, intermolecular forces, which is attractive in nature. Okay. They resist the separation between the molecules. So these are the attractive forces, but in between the same molecules. So these are called the intermolecular attraction forces. in opposite to the adhesive forces. Adhesive forces also intermolecular forces, attractive in nature, but applies for different molecules. It applies for same molecules. Okay. So whenever the molecules are different and there is attractive force in between them, it is called adhesive force. And whenever the molecules are same, feeling attraction force towards each other, it is called cohesive force. Okay. Now, for example, these bubbles, you can say these bubbles are with each other. So they are making contact with each other. Ice steam. So these, the forces in between these molecules is cohesive forces. They are stick with together because of the cohesive force. No. Now we will talk about the surface tension, and guys, please play very attentive to this because this is very important. Firstly, you will see this video. This is a kind of mosquito, you can say, or cockroach, whatever you like. So in the initials of the video, if you will see here, if you will see the legs of this insect pushing the water down, and here the water is acting like a stretched membrane, stretch film, है ना? ऐसा लग रहा है कि जैसे कोई कपड़ा है और इस पे इसके पैर जो है ना टेंशन यहाँ पे कॉज कर रहे हैं. ओके, सेम थिंग, बट दिस इज अ वाटर, दिस इज वाटर. So what property of water is causing this effect? We will talk about it. So how this water strider is able to walk on the water? Why? Because of the surface tension. Now, what is this phenomena? If we will see, whenever we take a string, let's say a rope, and if you want to develop the tension in it, what you will do? You will stretch it. So there are forces in opposite nature, equal forces which cause the tension in the string. And if you have a piece of cloth, you want to stretch it. So what you are going to do? You apply the same phenomena. You apply the tension, you apply the force in opposite direction, try to stretch it, so the tension will be developed in that. Now, in water or in liquid, what is happening there? Let me see. So this is the water. These are the water molecules. Okay. So this water molecule is attracted by this water molecule in this way. And if I talk about in this way, let's say these are the water molecules. So if I talk about this one, so it feels equal and opposite attraction forces from the other molecules also. So we can say that the net cohesive force on this molecule is 0, which means this is in the balanced state. Got it? But if we go up in this container at this surface, at the surface, so surface पे जब हम पहुंचेंगे, what will happen here? The molecule just below it will try to attract these molecules in all the direction. But so this molecule, the surface molecule, has cohesive forces of attraction in each and every direction. Why I'm not drawing the upside? Because there is no molecule up. There is no molecule here of water so that it can apply the intermolecular forces of attraction. So this side remains without force. So if we will see the net force, the net resultant of these force will be in the downward direction. Downward direction. So there will be no force to these molecules to compensate this downward force. Got it? And that is why this leads to the development of tension on the surface of the liquid. Got it? Let me explain again. Welcome, Shamila. How are you? So the molecules which is inside the liquid, they are not the problem, because these molecules have equal and opposite direction intermolecular forces of attraction. So the net force on a particular molecule which is inside the liquid is zero. So it is in the balanced state. But if you talk about the surface molecule, if you talk about the surface molecule, so in surface molecule, there is no compensation in this direction. In this direction also, only the downward force is there. So there is a net downward force, but to compensate this force, there is no force in the upside. Okay. So this molecule will be stretched in this way, because for stretching we need two force in equal and opposite direction. So liquid film, this liquid film will be in a stressed condition, and it is termed as stressed membrane of liquid. And because of the stretching, what kind of force can be developed there? The stretching will be caused by tension, and this tension is developing on the surface. So that is why we will say it as a surface tension. I hope you are clear with this. Now you can see this molecule, but there is no force in upward direction because there is no molecule in the upside. Okay. So here there is an unbalanced cohesive force. The net force is not zero on this molecule, which then surface behaves like a stressed membrane. I have already told you. Why? Because the forces are unbalanced. Got it? So this results in surface tension. So surface tension is the net effective cohesive forces in the downward direction of any surface. Got it? Because the net force, if you talk about it, the net force is in downward direction, because there is no molecule on the upside to compensate this force. So this force is nothing but the surface tension, okay, which is acting in the downward direction, and because of that, the surface of the liquid will be in a stretched condition. Got it? Now, force of the surface tension is perpendicular to the line considered on the surface and tangential to the surface. We will see it. This is the top view of this container. This is the side view, and if we look at this container from the top, so it will be look like this. So this is the top view, and let's say here is a molecule we have. This is the line, imaginary line we have selected. So on this molecule, we will not see the downward force, only these forces we will see. The forces on the surface. This is the molecule, let's say, at the surface. So these are the downward forces, but these are the surface force. These two. That's what I'm talking about. So that is why it is saying that force of surface tension is perpendicular. If you consider an imaginary line, so this force will be perpendicular to this line, but parallel to the surface. It is acting along the surface. Got it? So that is why we calculate the surface tension per unit length. So it is nothing but the force per unit length. In the previous chapter, the tension that we have taken is the force itself. Okay. But here, this surface tension is the force per unit length. If you take a line here, so the surface tension will be like this. Got it? The unit is very simple. The unit of force is Newton, Unit of length is meter. So it is Newton per meter. Dimension is important of it. It is mt raised to the power minus 2. And what kind of quantity is it? Is a vector quantity or a scalar quantity? So it is a tensor. What it? And what is tensor? Tensor has a single magnitude but multi-direction. What it? It is acting in this direction also, in this direction also, in this direction also. If you consider a line like this, so it will be acting in this direction, perpendicular to the line. So it is not bound to a particular direction. But magnitude, in terms of magnitude, it is force per unit length, it is same. So that is why it is termed as a tensor quantity. Got it? Which has a single magnitude but multi-direction. Got it? Now, see in this video, this is a setup and we will collect a liquid film in this setup. So this is the liquid film made of liquid, whatever the liquid is. And if we cut it from here, this acquires the minimum area. Look, if we make it down by external force, which is mg, so it will stretch it up. Now, what is the factor which is causing this? And that factor is the surface energy. Now, surface energy is the potential energy itself. The surface molecules, if you talk about the internal molecules, these molecules which is inside the liquid, and these molecules are at the surface. Okay. So if I want to pull this molecule out and I want to pull this wala molecules, this is molecule A, this is molecule B. So in which molecules I have to apply more energy to pull out? Definitely in B, because it is inside. So I have to go deep down and then I can get it back outside. So this molecule, definitely the inside molecule has definitely the greater potential energy than this, because it is required more energy. Got it? So that is why there is a difference in potential energy in the setup of surface tension. So surface energy is the potential energy contained by molecules of the liquid surface, due to which they stay on the surface against inward forces of attraction by other molecules. Because these molecules, the surface molecule is continuously attracted by the downward direction, molecules in down direction, but they remains there. Why? Because they contain the larger energy than the inside molecule, and this energy is termed as the potential energy, and we can say this energy to be a surface energy because this is acquired by the surface molecule. So that is why this energy is termed as surface energy of the molecule. Okay, so you will only have to remember what is surface energy. Surface energy is the energy possessed by surface molecule of any liquid, okay, due to which they stay on the surface against the force applied by the another molecules. What it? Simple सी term में surface energy is the potential energy of molecules present on the surface of any liquid. Simple. Now, if it is a potential energy, which is obviously causing because of the configuration. Now, the relation between surface tension and surface energy. Look, we have considered this setup and the length between two limbs of it will be D. D is the width of this wire frame. We are considering the same as we have seen in the video. And this is a slider which can slide on it easily. Now, there is a liquid film here. Okay. So what we are going to do, so this liquid film We know that the liquid film is going to apply the surface tension, okay, on this also, or this also. So this will try to attract this at a particular level. Now, what if I apply the external force? So I am stretching this film. So due to stretch, recall the concept of spring energy, spring potential energy. So whenever the spring in its natural length, there is no energy stored in that. But when we stretch the spring or the block attached to the spring, when we extend it, the potential energy will start developing in it because of the external work that we are doing. So it is the property of potential energy. Whenever an external force is encountered, the potential energy is stored in the system also. Okay. So we will take the block at some distance, stretch the spring by x. So there is some development of potential energy in the spring. And when we leave that block, the potential energy will convert into kinetic energy and gain back its original position. Got it? The same thing you can apply here. Since this surface is in a stretched condition, and we are all obviously we are stretching it by applying an external force. So by stretching it, some of the energy will stored in it in terms of surface energy of the molecule. And when we leave that, so this will come back because at that time the surface energy acquired by it converted into potential energy. Sorry, the surface energy acquired by this film converted into the kinetic energy, and it will gain back to the position similar to the spring. Now I have stretched it. Got it? From this particular length to this particular length. So the force will also trying to capture it again. In the case of spring, if I consider this case, this is in the natural length, and when I stretch it by a distance x, so there will be a force which is acting in opposite direction to our force, termed as spring force kx. So here the tension will be developed along this line. Okay. So the external force that we applied to overcome the surface tension force, F is equals to S into 2D, because S here is equals to force per unit length. Okay. So force is equals to surface tension into length. That is why it is S into 2D. Got it? Now, displacement in the direction of force, let's say x. So work done will be F into x, because it is work done is force dot product with displacement. What is happening? We will put the value of F. It is S into 2D. S we taken as common. It is 2D into x. 2D into x will become area of this film. Let me tell you this. Okay. 2D into this film we have. So x we have taken this. 2D is the distance of this. So the area will become length multiply with the breadth. So it will become 2D into x, which is nothing but the area. So the work done will here is surface tension into area. Got it? This work done is converted into potential energy. Whatever the work, this work is done by the external force that we have applied to stretch that member. So this work done will stored as a potential energy of the molecules at the surface. Okay. Because of that, surface energy will be same, S into A. So we can say that surface tension is also equals to surface energy per unit area. And surface tension is also equals to surface tension also equals to force per unit length. Okay, in terms of surface energy, it is given by surface energy per unit area. Okay, I hope you are clear with this concept. Everybody, any kind of doubt? Okay, got it. I want the response from everyone. Okay, any kind of doubt if you have, you can ask at any point of time. Now, surface tension is also the characteristics of the surface of liquid. Okay. Due to which, because let's say this is the film that we have, and this is independent film. So what it is being, there is a force development like this, as we have seen in the previous example. As we are going to stretch it, so there will be a force in the opposite direction to that, which is nothing but the surface tension. If we consider this length, the force will be perpendicular to the length. Initials of the definition I have seen. है ना? At that line, the force will be in perpendicular to that line. So for this line, it will be in this direction. So if you will carefully notice, this surface tension is decreasing, decreasing the surface area and decreasing up to what kind? Decreasing up to the minimum level. Okay. Got it? That is why it is written in here that surface tension is the characteristics of surface of liquid, due to which it tries to decrease its area, and for this purpose applies a force of attraction between the molecule at the surface. Because let's say this is the film that we have considered, and we are applying the force on it, external force. This is F external. Now the molecule present here will be attracted by the molecules present just below it. So they will tend, there will be a development of force, and per unit length, this force will be termed as surface tension. Okay. Now I hope you are clear with this. So we will move further in our lecture. Okay. Now, this is a film maker. So we will take a liquid film inside it, and we will put some of the threads with a loop, which means thread in this shape, but they are disturbed. Look at the video. And when we puncture it with the help of needle, that what happens you will see, and I will explain it why it is happening. So these are the threads. These are actually threads that I have tied at one end. Okay, let's see what happened. Dekho. When he or she punctured this film, which is in between these threads, it has taken a circular shape. Looking at it, why it is so? I have told you in just the previous slide, the surface tension, due to the surface tension, the surface will feel an attractive force. Because of that, the surface area will decrease. And up to what context? So surface area would decrease to the minimum value. Got it? And we know that in all the types of geometry, the minimum area is the minimum area is of circular. The area of circle is the minimum area. That is why when there is raining, so the raindrop, the liquid drop in rain is of circular, spherical shape, because sphere and circle has the minimum area of surface. Got it? And this is happening because of the surface tension. Okay, I will play it once again. Look at it. He has collected the liquid film. After collecting the liquid film, it has dropped the loop of thread inside it, but they are in not in the exact shape. So the liquid will come inside it. The liquid film also come inside these threads. But when we punctured it, so the surface of liquid which is around this thread will apply a surface tension. Okay, and that is why it is gaining a minimum area of. Got it? Happy? Now, due to the surface tension, it is taking this shape. This you can solve. A soap film is trapped between a frame and a wire of length 10 centimeter. If the surface tension is given by 0.0049 Newton per meter, what will be the value of M such that the wire will remain in the equilibrium? So what is happening? This wire will experience a force in downward direction. This is the external force. F is equals to mg. This mg try to pull this wire, but here we have a liquid film which applies a surface tension inside it. So at equilibrium condition, what will happen? The force applied by this force mg and this surface tension will equalize each other. Okay. Now we will see length of the wire is L, let's say. So surface tension developed is 2 into L into S. This is the force developed because of the surface tension. We have seen this expression in the expression of surface energy. 2 into length of the wire into surface tension. Now force due to gravity at equilibrium is equals to the force due to surface tension. So mg is equals to 2ls. So this m is into g key value 9.81. 2 into this, all we put the data. So we have calculated mass will be 9.89 10 raised to the power minus 5 kilogram. Got it? So I hope you are clear with this. Any kind of doubt in this question? It's a very simple question, let's say. So any kind of doubt? Anybody? Okay. Got it. Got it. Got it. Now our topic is excess pressure inside liquid drop, air bubble and soap bubble. If you consider a air bubble, a soap bubble, let's say. So soap bubble, I think you guys have also played with that. When we blow the air inside a pipe and there is a lot of big balloon type of bubbles form. है ना? I have also played with that. So in that case, we have already talked about the atmospheric pressure, which is it's a very high value, which is 1.01 10 raised to the power 5 Pascal. It's a good amount. But and that air around that bubble will try to collapse it, but it is not. Why? Because we can say that the pressure inside the liquid, the pressure inside that bubble is somehow greater than the pressure outside the bubble. And that is causing the difference in the pressure, and that we will say the excess pressure, the extra pressure that we have. Okay, and it is given by the pressure inside the liquid bubble and pressure outside the bubble. Got it? Because if the bubble is not collapsing, which means that the air outside the bubble is not applying the sufficient pressure, which means inside the bubble the pressure is high and outside the bubble pressure is low, which cause a difference in pressure. Got it? And this is what I'm going to calculate here. So it happens because of the surface tension, because we have surfaces in air bubble and in soap bubble also. So these surfaces where we have surface tension. Okay. So due to the property of surface tension, a drop or a bubble tries to contract and so compresses the matter enclosed. Thus, in turn, increase the internal pressure known as the excess pressure. So I will explain you by this. This is, let's say, the bubble. So this bubble at the surface, these molecules are applying forces on each other. Okay. These applying are forces on each other. That is why this surface has developed a surface tension inside it. Okay. Because of this stretching, because these forces acting in opposite direction, it will going to stretch it. Okay. And because of that, the pressure difference is getting here. Now, just a second. So this is the air bubble inside a liquid. We have seen it. Whenever you drink any kind of cold drink or soft drink, and you pour this into a glass of water, so there are bubbles coming out of it. So these bubbles are the air bubble. Okay. If you focus on this air bubble, which is inside the liquid, so inside of it, only air is there, and outside of it, only water. So there is only one surface of contact, which is water and air. Got it? And this is the air inside the balloon. Got it? It also has excess pressure inside it, because this air wants to blown out this, wants to coming out from this balloon. So that is why it is applying the excess pressure than the outside air. Okay. So in both the case, the internal pressure is greater than the atmospheric pressure. PO is nothing but the P atmospheric. So excess pressure would be Pi minus PO, because Pi is greater. So we will subtract this value from this value. So it is Pi minus PO, which is the excess pressure. Okay. Now, inside a liquid drop and air bubble, we will see the expression of that. So because of this internal pressure, we have considered this is Pi, which is the internal pressure of this bubble. The radius of this bubble is R, and this is the atmospheric pressure. Because of this internal pressure, it increases its dimension. Okay, R plus dr, let's say, because of this internal pressure, it has increases its dimension. And why it is happening? It is happening because of surface tension at the surface. It is going to stretch the surface. Okay, so that is why it is increasing the dimension of it. So we will consider it for R plus dr. Now the excess pressure inside the drop is P is equals to P minus PO. At equilibrium condition, whatever the work we have done in increasing the dimension, okay, will be equals to it increase in the surface energy because area has been increased. Okay, the surface area has been increased of this liquid drop because of this internal pressure has done some work to increase the area. So we know that surface energy is nothing but the, we will express the surface tension in terms of surface energy na. So it is surface energy per unit area. So if area is increasing, surface energy is also increasing. Okay, so here that is why we are saying at equilibrium condition, work done by the excess pressure inside the drop will equalizes the increase in the surface energy of the liquid drop. Because initially, let's say S is the amount of surface energy, SE is the surface energy of this bubble. This excess pressure will work on this bubble, try to extend the dimension of it. Now it has extended the radius by R plus dr. So all the surface will increase. The surface area will also increase. If the surface area is increasing, so the surface energy will also increase. Got it? So the work done, that is done by the internal pressure inside the drop, is same as increase in the surface energy because there is no external force which is working on the system. Only the internal pressure or the excess pressure you can see is working. Now, what is the work done by excess pressure? So pressure into area. वर्क डन क्या होता है? वर्क डन इज फोर्स इनटू डिस्प्लेसमेंट. Force here is pressure into area because pressure is equals to force upon area. So force will be pressure into area. Now you will put this value pressure into area of sphere is 4 pi r square into displacement. How much length we have displaced? R to R plus dr. So only dr is the displacement. This is the work done and surface energy would be S into delta A. Okay. Surface tension multiply with the surface energy. Got it? No. Delta A is the change in area. So original area, the final area that we have is 4 pi r plus dr whole square minus initial area is 4 pi r square. Now delta A will be like this. So you can ignore this dr square. Okay. So it will become, because dr square is very small, so we can neglect it. So delta A will become 8 pi r dot dr. We equate it. P into 4 pi r square dr is equals to S, which is surface tension, multiply by 8 pi r dr. This will cancel out each other. So they will become pressure, excess pressure inside a air bubble or liquid drop is 2S upon r. So remember this formula. This is for the excess pressure. Okay. Any kind of doubt? These are the soap bubble you will see on your screen right now. Now, excess pressure inside a soap bubble. Now, why it is different from the other bubbles? Because if you focus on the air bubble, inside of it is air, outside of it will be liquid. If it is inside a liquid. Okay. If you talk about the liquid drop, inside of it is liquid, outside of it is air. Got it? But if you talk about the soap bubble, inside of soap bubble is air, and outside of it will also be air. Now, this surface making contact with two surfaces, surface number one inside and surface number two outside. So, soap bubble has two surfaces of contact. One is the internal surface, which is making contact with air, and one is the outside surface. And let's say if this soap bubble is forming inside a liquid, so here we have liquid outside. So it inside surface we have air, and at outside surface we have liquid. So there are two surfaces here in this expression. That is why we are dealing in a different way with soap bubble. Got it? So the same thing is written here. Soap bubble has two surfaces which try to reduce the surface area of the bubble. Okay. These are the two surfaces you can see. This is the liquid film of dr length. So this will apply the same force in the perpendicular direction to the length we have considered. Look, at the cross section they are applying the force. Okay. So at equilibrium, same thing we are going to apply. Work done by the excess pressure inside the drop equals to the increase in the surface energy of the liquid. Now it is P into 4 pi square dr S into delta A, same thing. Delta A we have in this time delta A you will take 2 times of 4 pi r plus dr whole square minus 4 pi square. Because there are two surfaces in contact, so there will be two surface area. This is the only difference in between. Okay. So this 2 is because of the inside and outside two surfaces. Well, although the expression will be same up to here, so only a 2 will be addition. So in the case of air and liquid drop, the excess pressure is 2s upon r, but in case of soap bubble, it is 4s upon r. Okay. Now this will be the challenge for you. Now what happen when two soap bubble collapse together, and what will be the common radius after collapse? We have all seen most of the time when two soap bubbles come in contact, they will make contact and they will form a different soap bubble or different bubble. Now we are going to calculate what is the radius, final radius of that. Okay. And how the energy is increasing or decreasing in this. Okay. So we will deal with this question and rest of the other case in the next lecture. Okay. So till now, if you have any kind of doubt, you can ask. Otherwise, the lecture has been over. The rest of the thing we will discuss in the next lecture. Okay. So thank you so much, guys, for being attentive. Any kind of doubt, if you have, you can ask right now. Okay. Thank you so much, guys. Thank you so much for being attentive. Take care of yourself. Bye bye.